Hi, everyone. I'm Vijay from Harvard University. It's a pleasure being here. So today I'm going to talk about broadly around education and TinyML. And one of the things that Marco and I were thinking that we would do it a little differently, and Marcelo, I see you're here as well, so feel free to jump in as we kind of talk. But broadly, we were thinking about just kind of talking about some interesting themes and aspects of education around TinyML. Obviously, as we've seen in the previous talks, ML sort of, yes, there's a lot of, technical aspects that are involved with an ML, but as the keynote kind of laid out, there's a lot of opportunity as well with an ML. So the thing that we want to do today in the next, like maybe about 20 minutes to 30 minutes is kind of talking about the role of, TinyML specifically from an educational sort of standpoint. What are some opportunities? What are some challenges and difficulties that we may have around here? And Marco, I think it would be helpful for me if, and Marcelo as well, it would be helpful for me and for the audience if as I kind of step through things, like if you folks just kind of interrupt me and ask me questions so that way we can make it a little bit more engaging rather than make it just a regular presentation. Okay, awesome. So first things first, right? So obviously, as we've kind of heard throughout this morning, TinyML is obviously an interesting area where we're bringing machine learning onto these small little microcontrollers. Now, personally, I think one of the really interesting reasons as to why TinyML is extremely exciting about in education is because it's really a blending of different concepts and topics that we often talk about in the classroom setting when we're teaching students. So more often than not, like, when you learn about machine learning, for instance, as Jose was talking about, you're primarily just kind of focused around just the machine learning aspects of things. But, and then on the other extreme, traditionally, when you're talking about building any kind of embedded devices, like these small little embedded devices that we all, program and work with in classes, you're just kind of talking about, the input process output sort of paradigm of, working with embedded systems. And we often have to think about this in the context of a rich array of different applications, many of which, the keynote actually went on to, right? And what I think is really interesting about TinyML is that rather than treating these areas as completely disparate topics, as in there, okay, this is about machine learning, this is about embedded systems, this is about applications. What I think is interesting is that it's really a blending of all three topics, put together. And I think personally, from, having taught multiple times at school here, I've definitely realized that students actually have a much deeper engagement and as well as interest in learning about TinyML because they learn a little bit about all three of the pieces, and then they get to put it together in some sort of projects. And I think, and that's particularly why I think TinyML is so exciting to be able to put it in an educational setting because it's an application of a lot of the fundamentals that we learn. And of course, it's got its own optimizations like, quantization and so forth, as we heard about. And, over the recent couple of years, there's definitely been a lot of momentum in terms of, TinyML education, broadly speaking, across many universities. And one of the reasons I think that we're seeing a lot of momentum around TinyML education is particularly because, for one, as I said, it's the intersection of these different topics. The second thing I think is very interesting is that it's for the first time, it actually makes ML a hands-on aspect. But typically, when we're teaching anything to students in the classroom, we're often talking about, theoretical aspects, or, even if you have some sort of, chemistry lab or biology lab, you have to do something with it. And that's the reason we have labs. And so students go in and do actual chemical experiments or biological experiments. And I think TinyML with the small form factor makes it a very applicable thing where you can actually have labs where you're actually able to do person detection or you're actually able to do keyword detection. And so students can actually build a whole project out. That I think is what makes this ML or AI look not so much as like some sort of, very complicated technology, but it actually brings it down to us, which I think is extremely interesting. And the last thing on this slide is like, what age groups generally benefit from TinyML education and outreach. Arguably, I think TinyML benefits the entire ecosystem of educational spectrum. I remember, for instance, when I was at UT Austin, we used to do embedded systems with, sixth graders and seventh graders. So that was because it was just embedded system. With the TinyML, now that, as the keynote kind of pointed out, lots of tools have come about. So you can have no code solutions, which allow, even K through 12 students to be able to interact with machine learning and understand the general concepts as Jose was explaining. But
Vijay, I have one question. So
yeah,
when you show the picture here on the right with the three kind of domains, how do you balance I would say two domains, right? Machine learning and embedded systems when you teach? Is it like
yeah,
half and half in terms of time, or?
I would say that it's definitely half and half, yes, because you have to know a little bit about what are the constraints we're talking about embedded systems. So I think students learn a little bit about how is an embedded system fundamentally different from a mobile phone or a big supercomputer. And the ML side, it's not core theory of ML as much as it is about applied ML, right? When we write a programming language, when we write some code, let's say in Python or C, there is actually a lot of theory behind those programming languages, but we often don't talk about that theory. Rather, we look at it purely from an application sort of a standpoint and applying it. So that's why I would say it's a bit of half and half.
Vijay, following this question, Marco's question, uh, what do you see that's more complicated? Let's say electronics engineer or embedded engineers to learn about machine learning, or the opposite, computer science students to learn electronics. It's always because I think it's not easy to find professors that would like to have both subjects. Maybe when they see that the how easy or how you can understand the global scene with TinyML, this helps a lot. But at the beginning, it's very difficult. No, it's a kind of a barrier. No.
Yeah, that's a great point. So I think it's generally people specialize in one of these areas, right? It's either ML or embedded systems, and I think that's what makes it. That's what I think like this whole TinyML is going to create a whole new set of new engineers that we have not seen before because they're going to have a melding of both machine learning and embedded systems. Traditionally, I would say embedded systems, people think, oh, ML is some sort of magic, so they have to learn a little bit about it. If they're ML engineers, they often have no idea about the hardware constraints and the difficulties in programming and dealing with the heterogeneity and so forth. So I think this is why I think we're going to see a new branch of engineers. I'm pretty sure, some of the people from this particular room alone will be, the new set of ML engineers that we're going to see. I mean, I'll stop after this, but the point being that I genuinely think that as much as we're all talking about TinyML, I think that most interesting applications are going to come from the people that are on this call as compared to people like us who actually understand the technology, because we're already jaded with some sort of perspective of how computing systems are used and so forth. So I think it's the next batch of engineers that'll actually open up a whole new world of, applications. That's a great question, Marcelo.
Thanks.
And of course, like Marco and Marcelo, if there are questions in the chat that are relevant, could you just kind of, I'm hoping we can have an interactive discussion around this topic. And the slides are really just there to kind of have some format. So what are some integration and applications of TinyML in education? Right. So one of the questions is, how does TinyML enhance the traditional educational aspect? And then what are some practical applications of TinyML in the educational setting? And can we provide examples of how TinyML is being integrated into existing curriculums? And I think, how does TinyML enhance educational methods? I would say that typically when we teach about computing systems, especially embedded systems, I remember the very first time I ever taught an embedded system class where I was introducing them to, small Arduino boards and so forth. And I said, and the example that I took there to teach them was a garage door opener, which has a very simple microcontroller inside. And my class was 400 students. And I was very excited that day when I was like, okay, I'm going to show them this whole class is like embedded systems, and it's going to be about this garage door opener and how it works. It's so simple, yet it can do these amazing things. And after I was done, I realized that no one was excited about it. Only I was the excited one in the whole classroom, because I was like, oh my gosh, and it was not until I finished the class and then I went back and then I realized that, oh, students today probably don't want to dedicate their lives to building garage door openers, because that's effectively what I was telling them. By learning about embedded systems, you can build these kinds of devices. So I think TinyML makes traditional topics like embedded systems, which are basically dealing with these small microcontrollers, much more interesting because you bring them to life. You can get them to do things that have not been possible in the last 50 years of microprocessor design. And I think that is one of the unique value adds of bringing TinyML and adding a little bit of machine learning onto these small devices, right? So I think that really enhances the educational methods. In fact, we ourselves at Harvard are actually revamping our own introduction to embedded systems using TinyML as the basis to make it much more engaging for students to learn. Then what are some practical applications of TinyML in educational settings? I think TinyML brings, you can teach them about embedded hardware. So there's a lot that obviously happens in the embedded hardware, sort of how do you use timers, how do you use, these microcontrollers to, control the world around you. And what makes them obviously interesting is that most often when you're talking about ML, for instance, you're talking about, okay, I can detect a cat versus a mouse or a dog or something like that. But all of the real work is being done somewhere else, right? They're being done on some big machine someplace else. And I think what makes TinyML so interesting is that you can actually fine tune it for the exact application or use case that you can invent. More often than not, when you learn some concept, these concepts are just kind of talked about in abstract, right? Imagine like if you have to say, okay, Google, or you say, hey, Alexa, and so forth. Those words are all kind of predetermined. You never really get to program those devices. From an application standpoint, it's always awesome when you see students being able to use their creativity in addition to the core engineering that you have to do, because then they can get it to detect any word you want, right? And I think that sort of opens up this aspect of, okay, what are some potential new projects and applications that we can do? I think that's quite unique about what TinyML does. It's a blending of theoretical and practical aspects with a bit of creativity about how you can do. So very often when we have done projects here, people have used them for robotic applications. People have used them for healthcare applications. People have used them for conventional sort of, consumer facing applications. So students come up with all kinds of creative things. One of the coolest demos that I saw in my own class project was actually they built a candle, something that turns off a candle. And basically it's, you get often when you're, you light candles, the biggest problem is you have to make sure you turn them off or you blow them off. But they built a small little widget that would basically respond to kind of, shutting it off. So it's a very small widget that you kind of clip around the candle, and then it just kind of drops onto the flame, and then it shuts the flame off. So those kinds of applications I would have never thought about, right? So I think that's very, very interesting, this interesting balance between creativity and sort of pedagogical aspects. Can you provide examples of how TinyML is being integrated into the curriculum? So I've seen TinyML now being integrated into traditional hardware classes. I've seen it being integrated into machine learning classes because they can, again, depending on where you want to put the focus. If you're an ML, you're often trying to bring the ML closer to the end user. So, the ML people are becoming interested in understanding the resource constraints. The embedded systems people who build all kinds of interesting hardware are very interested in actually being able to sort of make those embedded systems smart. So I think both ways we're seeing a lot of innovation and creativity around here. And I think one of the most amazing things about TinyML devices is that you get this ability to kind of look at the whole spectrum, right? You get to go from collecting your data, doing all the processing, building a small little neural network model, which you can do on your computer, then actually optimizing it, and then finally deploying it. And I think closing this whole loop has traditionally never been possible in the past. More often when you're talking about cats and dogs, for instance, yeah, you still need thousands of images for doing cats and dog classification. But with TinyML, if I'm just detecting keywords or I'm trying to detect whether there's a person or no person, then I can collect a little bit of data. All of that data can be collected. So you learn how to build a machine learning data set. And then you learn how to deploy a machine learning model on the embedded device, which I think is a very, very powerful pedagogical concept because you can walk them through the entire life cycle of deployment. Not only that, after you deploy it too, you also want to be able to go back and improve the data. So in our classroom projects, students have actually deployed the models, then found that it doesn't work for certain color of people or certain environments, and they realize that, and then they go back and update the data. closing that full loop, especially as a student for the very first time, I think is a very powerful concept because you really get to understand ML. And so in terms of resources, I wanted to provide some resources. We have, some sort of educational professional certificate program for, learning TinyML. For all students, I'd say you shouldn't pay. You can totally take it for free, and that's what you should do. Even though it'll say it's a professional certificate, but students can basically learn it for free. So that all sounds fun in terms of, being able to deploy TinyML in the classroom and getting students to kind of work with different kinds of embedded devices. But there are obviously challenges, right? So I want to talk about what are the challenges that some of the educators will face when implementing TinyML in the classroom. And then are they, ethical or equity considerations around the use of TinyML in education? So first and foremost, I'd say that, what are the biggest challenges that most educators face in practice? What we have found is, most people are dealing with this plethora of different hardware devices that are there, which is a good thing. Generally, if the richer the ecosystem, driven by the open source ecosystem, it's a good thing because then you have a lot of different options. But when you have a lot of different options, it becomes difficult to understand which particular device is good to be using as a classroom tool. And then, that often ends up becoming a problem because, people are trying to figure out, okay, what sort of software do I have to worry about? Because, you cannot assume that something like CircuitPython or MicroPython, which is great for programming microcontrollers at a high level of abstraction, is actually available on all the different devices. So that's one problem. Of course, then there's also issues, with what kind of configuration that is actually good for all the different exercises that you want to do. Because some microcontrollers have much more memory, like, this one has, 128 kilobytes of cache, flash, and this one has 16 kilobytes of flash. But of course, there's a difference in price too, right? So that's another element, so which leads to all this heterogeneity. So there's this really nice DigiKey book that lists all the different sort of boards that are actually available now for running TinyML. But I think arguably the most important concern often ends up becoming, what is the cost of the board? So this TinyML kit that when we did with Arduino, this TinyML kit, which we thought was very cheap, was still like around 50 to 60 US dollars, which we thought was very cheap, relatively speaking. But in the end, it was still very, very expensive when we were talking about reaching a large amount of ecosystem. And but as you can see, over time, boards have actually gotten, there are many, many boards that are becoming more and more capable of this. So cost is increasingly dropping, which is a good thing. But we definitely realize cost is a big thing to factor in, and that in turn affects, what kind of capabilities we can teach with TinyML. The ethical and equity considerations, I specifically wanted to just kind of mention the equity aspects because, I thought $50 was a okay price to be able to teach, to be able to make things accessible. But obviously, as we later found out, $50 is actually very expensive, once you factor in all the overheads involved with getting boards into, foreign countries. So I think this is perhaps one of the biggest things. A lot of the benefits. Yeah.
We have a few questions in the chat, so maybe we want to go through them. So one from Beatrice, she was asking, do you think that TinyML can have a similar impact on people with no prior experience in programming, electronics, or machine learning as Arduino has had?
Yes, absolutely. That's a beautiful question. 100%. I really do think that TinyML has that exact same potential. TinyML is not a new thing, right? It's over time, we're slowly building one on top of the other. And Arduino enabled us to have low cost, but really flexible platforms. And I think TinyML, a lot of the software like TensorFlow, like Micro, the Arduino's own libraries, all of those are making it very easy to deploy, which is what the keynote was also getting at. And I think that's why it has the ability to honestly democratize what AI is. If you look at AI is a very, specialized piece of technology that only a handful of people really understand it and play with it. Why? In the past, you needed these very large models to work with. But now we're able to work with very small models. Therefore, I think it's going to completely transform the way we look at AI in the next few years. Marco, any other questions?
Yes. Second one was about the timeline. So what are examples, timelines to build a small project using TinyML?
Yeah, so there are lots of really good examples. I think Marcelo should get a lot of credit on this. He himself has put many different tutorials that you can actually get your hands on, and you can work on them. But I think if it's from a maker sort of a standpoint, then certainly I think, one can start doing something immediately and be able to have a small model deployed within, 3 to 4 days. You should be able to get a small embedded device, play with it, deploy a small little model that does some sort of classification or some sort of voice recognition or some sort of activity detection like shaking hands. So I think that's remarkably powerful, right? You can collect the data, you can deploy the model and do all of that within, a few days. And I'm saying few days because I'm taking into account like, oh, you have to get the device working and so forth. So
yeah. And then there's one last question from Rasesh. Can we use TinyML with system on chip?
the embedded systems are SoCs, right? So the answer is yes. But a lot of these embedded systems are, in fact, like, truly just system SoCs. So yeah, the answer is definitely yes. There are variations in the type of SoCs, but nothing fundamentally stopping us, right? Good questions.
Super.
So yeah, so what are the benefits, right? So we have run a lot of different workshops. So this is a workshop that Jessica Quay, one of my students, actually ran in Ghana last year, where with the Mice Foundation. The Mice Foundation is a program that she came through before she came to MIT and then later joined Harvard. But when she was a high school student, the Mice Foundation, would bring in some of the best students from Ghana and in Africa all together, and they would select about 15 students to teach specialized programs. So, and she came through that program, so she was very passionate about giving back. And it's amazing, right? Because they used to teach them computer science. And we thought, okay, why not take computer science and add a little bit of AI? Typically, you cannot do that because, again, cost is prohibitive. You need large models, you need big fat computers, all of that stuff. So the reason I picked these particular pictures, to show is because these kids were simply, they're using the small, if you look at those boards are the exact same boards that, is as this, right? And they're able to use them hands-on and then just train the model and do everything just locally on their computers, which makes it very accessible. And of course, students, because they were dealing with a physical device, they could think about different applications and use cases. And this way, it's like we were able to expose the students to computer science principles, to embedded systems principles, and a little bit of AI. Again, the combination of all three things is what makes TinyML click, right? And of course, that got them very excited about thinking about, oh, yeah, I definitely want to continue to learn more of this. And honestly, some people were thinking about, various other kinds of, career programs they wanted to do. But after taking the workshop, several of them actually ended up saying that they're very interested in learning more about computer science, more interested in STEM related topics. And professionally as well, like, we're starting to see more jobs getting created around this. So there's actually at the next summit, hopefully, like, there will be like, more options where people can apply for jobs and so forth. Now, that's primarily from a student sort of a standpoint, but the question is like, what do educators need to know? Because for us to be able to teach the students, we ourselves need to learn, right? And the field is constantly changing. So just to give an example, one of the best ways of scaling some of this educational outreach is we had students, from instance, from our universities and other universities basically learn the material, learn the TinyML material, and they get credit for it as part of learning and teaching the junior students, this cohort. And in doing so, they actually get to, they basically help the educator. So, here's one of the students who's actually helping. And so he actually flew to Ghana, spent, about 2 weeks down there. And not only was he teaching the students, but he was also teaching the teachers how to teach this material. So mostly it's the same as we're all students at the end of the day. I think that's the most important thing to kind of keep in mind, is that even we have to learn. And we have done quite a lot of workshops where we actually paid for teachers to actually spend a week with us so that we can actually teach them stuff, because this is extra work they have to do. So what kind of resources are available in order to help with teaching? So obviously one of them that Marcelo, Jeremy, Marco, and several other people are all kind of obviously been helping around is like, this, and Brian Plancher is around putting together all the resources that are relevant to get started. So this website down here has a lot of resources in the courses and materials section where there are lots of slides and everything is available in the open source community. More recently, personally, I'm very passionate about, giving outreach. So I started writing a textbook because for machine learning systems, there is no book out there. So I ended up writing an open source community book. And I say it's open source because it's anybody can contribute. Just yesterday, I was getting contributions from someone from a different part of the world, and everybody's kind of helping improve it. They were finding mistakes that I had written in and then correcting those mistakes, which is awesome, because even I'm not like, it's not, I know stuff, but in my writing so much, it's like, it's easy to make mistakes of my own clarity. So I encourage you to check these resources out. This particular page has a lot of really good resources from all the different workshops that ICTP has been running. In terms of, where are, most of the time we often talk about consumer facing applications, but I wanted to just kind of show some interesting researchy kind of things and future trends. I think someone mentioned earlier that, you can use, drones and so forth for actually doing things. So let me I might actually have to enable, I'm going to stop and reshare because I have to enable the sound, I believe. Okay. Yeah, so I'm just gonna play like, one of the things is like, what can you do on small little drones, right? So here's a simple. So I'll stop down here. As you can see, like, there's interesting applications of, these are very, very small drones. And this is a source seeking drone. So it's actually trying to find, some sort of signal. And the signal down here happens to be light. In the next one I'll show you, it's actually source seeking to try and identify where gas is leaking. Source seeking is a very powerful concept because in search and rescue applications and so forth, if someone is screaming and the building is completely collapsed, you want to send these very, very small sensors, but they have to do obstacle avoidance. They have to learn how to, navigate in an environment all by themselves. So those are fairly sophisticated tasks you have to do, and you have to do this on extremely small resource capabilities, right? So as you can see down here, there's only one core. It's basically any frequency improvement, and then with very, very little memory. All of these things which have been discussed earlier, but you have to imagine trying to get all this intelligence packed on here, and it's possible. That's the amazing thing, right? So here you saw just like one drone kind of working, but like, here's another example where if you can enable TinyML, you can really enable some crazy future trends.
A dangerous gas leak in a building. Wouldn't it be great if we could send in robots to find the gas leak quickly and without endangering human lives? We have developed the first autonomous swarm of tiny drones that is able to find gas leaks in unknown, cluttered environments. Their small size not only allows them to fly in narrow spaces, but also makes them very safe. Usually, it is very challenging to get such tiny drones to fly autonomously due to their small processing power and little memory. To solve this problem, our drones use a bio-inspired strategy in which they follow a few simple rules. They start flying in a random direction for maximum exploration, avoiding obstacles on the way. If one of them smells gas, it communicates with the other drones, which will help to better localize the source.
So you can see, right? So it's not just one of these devices. They can also collectively communicate together. But again, to be able to do that, as the video was saying, we had to develop on-device intelligence capabilities, be able to squish the models down, embed that on device, and actually get them to do communications in real time while trying to avoid obstacles. So, but all of this is possible if you're really pushing at the state-of-the-art research. So sort of like, thinking about examples of, stories or case studies where, TinyML has been successfully used. Obviously, I'm coming from I've shown you an example of the K through 12 workshops that, we do, for instance, and many other people also do them. Like Marcelo has run many, many different workshops like that. But the ones in universities I can point out, for instance, like, I teach them here at Harvard, obviously, every year. MIT also teaches them. Professor Song Han there is amazingly exceptional at, doing very efficient deep learning, which is his specialty. And then, of course, Professor UPenn, Professor Amishad UPenn, he does things more focused on autonomous vehicles. So, he's got his own variant of the TinyML course. And of course, Brian, Marcelo, Jeremy, I should add you in as well as here. And Marco, we've all been working together to try and make sure a lot of whatever educational materials that are coming from this or the Harvard X course and so forth are publicly accessible. So, we've been working on creating this sort of, academic cohort that is distributed. And one of the key things that we try to do, obviously, is try and package all our materials and make it accessible for everyone. So that's just the tip of the iceberg in terms of, what we can do with TinyML in terms of education and how we can enable, educators to actually be able to use this, to be able to teach this in the classroom, and what kind of resources are available. On Wednesday, as you can see down here, it's primarily focused on education and interesting applications, so you'll certainly learn a lot more. But I'm happy to take any questions that might come up.
Yeah, thank you. Yeah, thank you, Max. Thank you, Vijay. That was super interesting. I'm going through the questions, and there were a few. Okay, something about the network. We're going to discuss that on Friday in more detail. Okay, this was one which was about programming languages. So the question is, so TinyML does not have to do with your programming language. Is it Python, MicroPython, C, or other languages? Could one use MATLAB Simulink for just connecting the blocks? And how about the newest language, Julia?
Yeah, I think languages, lots of people are trying to integrate, Python has been trying to integrate this in, but I think I would say that it's really less about like which particular languages are kind of the interesting aspect. I really think it's just about understanding the constraints of the system. I think the language ecosystem is going to change quite a bit in the coming couple of years. I think we're increasingly going to see basically no code systems where you can, you don't have to really understand code, but you really have to understand data. The big thing when I say you don't really have to understand about deploying models here, people often think I'm saying, okay, you don't need to know programming. My argument is no, you actually have to know programming. You just have to know a very different type of programming. Data is the new code, and data is what controls the network. So you really have to understand how you program with data, if that makes any sense at all. You have to really understand how data quality, how data augmentation-based methods and so forth actually you're effectively programming the network on the fly. Typically we write the code and then we run things. Here, you put the network up, but the code is really the data, and the data is what triggers the network. So you really have to understand how you quote unquote program with data, which you can talk about Julia, you can talk about MicroPython. I think they're all absolutely irrelevant. That is not what you should really be worried about. You should really learn to program with data. There are no classes on this or anything. So this is one of the issues, but increasingly it is becoming obvious that you have to systematically understand programming the model by controlling the data itself. So that's my response.
Yeah. So there's one live question from Amied, please.
Yes, as a follow-up to my question about the programming languages, how about MATLAB Simulink? Has anyone worked with TinyML with MATLAB Simulink? Because in Simulink, one just connects blocks together instead of integrating and doing mathematical processes. And it is also used in the automotive industry. In MATLAB and Simulink, one could generate a C code out of a Simulink diagram, and everybody could use Simulink. So Is there such a possibility in TinyML?
I personally have not used Simulink to be able to do this. So I don't know, Marcelo, if you've kind of done anything like this, but I would not be surprised if
No.
the capability is not there. I wouldn't be surprised if some of these things are coming down the pipe. So, but again, I understand why you're asking the question, but again, I almost think that it's going to become almost irrelevant how we actually program the device. Because I would say that was the last decade's worth of interesting work, not the next decade's interesting work.
I would add though, Vijay, that the TensorFlow Lite Micro, right, has a Python front end and generates C code, you know, and there's a bunch of examples of like Google Colabs that can do that. So there are already, as Vijay's saying, lots of ways where you can do code generation from a friendly interface to get things out. And yeah, it'll just keep getting better.
For some of the training activities, especially the short ones, I use Teachable Machine from Google. And I found that tool to be extremely interesting and useful for the, educational point of view. Because it really, and as you said, Vijay, I mean, there's no coding, right? You focus on the data. So the exercise there is about, coming out with some basic examples for one person and then having that same running model on another person, for example, on, face detection or mask, no mask, and so on. And that doesn't work because you don't have enough data as a data set to train the model with. So I think from the education point of view, it's great. I will share the link in the chat if people don't know it.
Mentioning data, the data comes from a sensor. For example, a door car, it doesn't close very well. There is a sensor that senses it, sends data to the embedded system. The embedded system sends data to a light, a bulb, into the car, and it lights that this door is not closed very well. So this is the data exchange. It comes always from a sensor, whatever the sensor could be. It's sometimes very complicated, a camera, a radar, LIDAR, infrared, something like that. And then there is the embedded system in the middle. Everything comes to the embedded system, which has inside it a TinyML. And this TinyML gives a response to an actuator, whatever this actuator is, whether it's a light bulb or any other action. So it's exchanging data actually, but in the middle there is a system which should be programmed in some language. I mean, as I said, in the automotive industry, they prefer Simulink because everybody could learn it very quickly without going deep into the programming syntax and all the debugging things. And they could generate a C code, which is very light from this Simulink, and put it onto the embedded system. Thank you.
Yeah, I agree. I mean, I think, yeah, increasingly we'll just see more and more of these kinds of, high-level platforms that make it super easy to deploy things on.
Okay. Marcelo, any comments?
Well, a lot of people are asking about kits, how to purchase kits, etc. As Vijay said, the Arduino kit, this one that Vijay show for you guys, something like this, it's very nice because you have a lot of let's say classes, courses doing over it, no? But nowadays you can find a lot of devices, including much more cheaper than that. If for example, if you go for the Expressive ESP32 family, you can find with a few dollars small microprocessors that you can use to learn and to teach. You can, of course, you can buy devices with a microphone or accelerometers integrated, or buy outside and put close together. As Vijay said, you have several tutorials on that, and including all the links are available in the let's say the link of Discord that we are always trying to you guys to enter there, put your questions there. I mean, again, as Vijay said at the beginning, hardware is not the complex thing here. You can also nowadays you can find very, very good, fantastic devices, not very expensive, available all over the world, and you can start to learn these kind of things. Other possibilities, including some people ask here if you really need how we can start with that. For example, if you use let's say no code platforms like Edge Impulse that Marco commented at the beginning of the day, and you guys will learn more about that Wednesday with Sean Himmel. You see that it's a free platform. You can go there. If you don't have a device, you can use your own smartphone, because with your phone you have a camera, you have a microphone, you have a accelerometer, so you can use those sensors connected with the telephone, the cell phone main processor, let's say to capture data, to go to all over the process, to train, testing, and deploy the final model again to your phone. So I mean, so you can understand that this is good for teachers, is also good for students. So there's a lot of platforms. So it's not complicated to start and to learn. The big mess and the problem are with data. Data is very complicated. And talk about that, I also would like to listen from Vijay. I know that Vijay is working in a new kind of a data set that's related to vision, because, for example, I'm a teacher and I use with my students, for example, very nice data sets that was developed by Peter Warden a few years ago for sound, for when you can classify words like yes, no, or Alexa, Google, it's such kind of things, no? But now I think that the Vijay is working with some more, let's say, interesting data sets regarding images. No, that's correct, Vijay?
Yeah, that's a good point. I'll actually explain real briefly. Yeah, sharing the wrong one here. So, yeah, Marcelo is right that we are working on a new vision data set, and one of the vision data sets that is wildly popular in TinyML is what's called the visual wake words visual wake words. So this is a data set that is widely used for doing any sort of person detection and so forth. And one of the challenges now is, like, if you want to train models that are really good, then the visual wake words data set actually is a great start, but it's not enough. And so you need to have like a really rich, diverse set of examples. You need to have, different kinds of people, young people, old people, people that are near or far, because it's all about images. You need to control the brightness or the darkness of the images. You need to be able to tell whether it's a real person, like as we're seeing down here, or is it a person that's just depicted. So there's lots of nuance involved in how a data is collected, and the data sets need to be strong enough. So this is one data set that we actually just recently kind of released, Wake Vision, which is 100 times larger than any other data set that's available for TinyML. And this allows us to kind of really push the models to be much better. So in fact, if one trains on this data set, the accuracy of the model is actually much higher if the model is really good. Because depending on the data quality, there's only so much that the model can learn. It cannot be any better than the data that is, that the model can learn. It's learning from whatever data is available. So we ended up creating this very, very large data set that helps us kind of address this point. Again, this is just the tip of the iceberg. Like this, one of the key things is, it can cost a lot to build the data sets. So there's a lot of really interesting work going on, and how can I synthetically create data to be able to augment some of the data sets. So we actually do some of those kinds of things. But long story short, the point is basically that data is extremely important. And I think like over the next 10 years, we're really going to focus on building better data for TinyML, because I think that's one of the weak points for TinyML.
Yeah, that's great.
Super. Any more questions? Or okay, so Rodolfo, please.
Thank you. Something I need to say is that I actually don't know much about ML in this moment, but this is very interesting to know it for the first time. But I would like to know more about that thing of programming from the data instead of thinking on the language. So you are explaining we can use different types of data and we can obtain it with different cameras, microphones, and that stuff. But what do you mean about this programming from the data and thinking on the data instead of languages?
Yeah, so traditionally when we're talking about neural networks, right, what we end up doing is really focusing on right, like I'm like totally doing this on the fly. Traditionally, we focus on, okay, I've got some sort of neural network model, like, you know, I have some sort of inputs I'm going to look at, I have some sort of hidden layers, they produce some output, right? So based on some connections, we can train these kinds of networks, right? So they might be shallow networks, or you progressively end up making them deeper and deeper. And that's what you focus on, which is the neural network architecture, which Jose was kind of talking about in the context of, like, okay, there are transformer architectures, there's, you know, different kinds of, you know, state-based models like, you know, Mamba and so forth, that are just kind of like different ways of doing things. And over the last many years, we've really focused on understanding how deep should the network be, right? And how to connect the different things together. That's where most of the work has been, and people will just take a static data set that says, okay, I got 10 images of dogs, 10 images of cows, and then, you know, feed that in, right? But we don't really talk about what's the quality of that data, right? Like, are those 10 images of the cow basically the same exact image of the cow? Or are they slightly different enough that no matter which angle I look at the cow from in the image, it actually, you know, still recognizes a cow, right? And so that has been a data science sort of a problem, which is kind of like, you know, people have talked about, do I have enough data? So one of the ways people have dealt with the problem is, let me just kind of make the data bigger and bigger and bigger. So as long as I basically take the whole internet in, I'll probably have a good enough idea about what the, you know, that I'll capture all of it. But there has been recent awareness that it doesn't matter, you know, how much data you have. What really matters is not the size doesn't matter. It's the quality of the data that actually matters, right? And so that's this paradigm, or, you know, wave that we're seeing now, which is data-centric AI, which is you can lock the model down instead of changing the model aggressively, making it deep and all that. Instead of doing all that, you can just lock one particular model down, and then you change the way you actually put the data into it while teaching it. And that basically, you know, has a much higher impact. Think about it another way. We don't need to talk about computer science and all this stuff. Think about it. We're all born basically with a certain brain, right? I mean, you're stuck with that brain. Like, you're not like gonna go in and suture it and like rewire the neurons and so forth. Instead, what do we do if we want to learn better? We focus on the experiences, right? We focus on, like, you know, with my kids, we're always thinking about what are the different things we should expose them to, right? And it's the exact same thing like that we should be doing with these neural networks. You get some brain, not a big deal. The brain is good enough. It's got a lot of capability, right? And then you try to figure out what are those different experiences. And we do this very systematically when we look at the real world, right? We built curriculum programs from, you know, kindergarten. We understand at each level what we need to teach them so that their understanding is actually building on, you know, systematic layers. When we're programming networks, we don't think about things that way. We just suck in whatever data and shove it all into the network and say, okay, you just learn whatever you learn. But that's like a really stupid way of thinking about the world. We are so careful about what experiences our kids have, you know, where are they going, who are they hanging out with, and all those things. That is data curation. We're controlling what their experiences are by showing them or emphasizing certain good parts showing them a little bit of the bad parts, labeling that as a bad thing, right? And then kind of enriching that experience. That's the exact same thing that we should be doing with neural networks. And that's effectively what I'm talking about, Rodolfo, that, programming with data is like controlling those experiences that the network sees when it's learning. Hopefully that analogy kind of explains it rather than kind of getting caught up in data-centric AI and all that craziness.
That's an excellent example, Vijay. Really, really nice. I think we can call it a day. So again, thank you so much, Vijay. Thank you all for the wonderful day today. And we meet again tomorrow at the same time, same room, for more talks.
And guys, please don't forget, enter in Discord. People that are not, it's very easy to enter, and you'll find a lot of discussion that you had today. The answers are there. And we hope that during the day till tomorrow, we'll have all the presentations up in our website, and we'll put that in Discord, also in Discord. Okay. Thank you.
Okay. So see you tomorrow.
See you tomorrow, guys. Bye-bye.
Bye-bye.